Hello everyone. Welcome back to Learn Smart with Sweta. This is part 4, the final part of our Trigonometric Identities series based on the R.S. Aggarwal Class 10 Mathematics book for the ICSE Board. In the first 3 parts, we covered questions 1 to 30. And in the final part, we will solve questions 31 to 42 from the Prove the Following Identities type of question from first exercise. I am following the R.S. Aggarwal book prescribed for the 2026 board examination. If you are using the latest edition, you may find 1 or 2 questions or their sequence slightly different. So let's begin with question 31. 30. For cot A, we will write cos by sin, and for tan, we will write sin by cos. Let's solve. So, cos A by sin A minus sin A by cos A. Next what? We will take LCM. So we will get sin A into cos A, and here we can write cos square A minus sin square A. Next what? Next, let's write this sin square A as 1 minus cos square A. So we will write cos square A minus 1 minus cos square A upon sin A into cos A. Next what? Next, let's simplify the numerator. So we can write cos square A minus 1 plus cos square A. Cos square A minus 1 and plus cos square A. Denominator will remain same, sin A into cos A. Sin A into cos A. Now numerator, let's simplify. Cos square A plus cos square A, we can write 2 cos square A minus 1 upon sin A into cos A. And if you see, this is what the RHS is. So we have got the RHS and we can prove it. Simply we have done cot for cos by sin and we have done tan and sin by cos and just kept on solving and you are getting the RHS, right? Let's see the next question, question number 32. So this is question number 32. Let's see how to solve it. So LHS we will solve, and how do we solve LHS? So see, in the root we have 1 plus cos A upon 1 minus cos A. Now for such questions what we do like rationalizing the denominator. So what we should do, here in the denominator we have 1 minus cos A. So we should multiply it by 1 plus cos A. 1 plus cos A, we are multiplying the denominator, and 1 plus cos A, we are multiplying the numerator. So what do we get? We get 1 plus cos A the whole square. 1 plus cos A into 1 plus cos A, we can write 1 plus cos A the whole square. And denominator, we have 1 minus cos A into 1 plus cos A. So we can write that as 1 minus cos square A. 1 minus cos square A. Now what? Again, let's write the numerator as it is, 1 plus cos A the whole square upon. And this we can write as sin square A. And now see, under root we have 1 plus cos A whole square. So we get 1 plus cos A, square root of 1 plus cos A whole square is 1 plus cos A, and sin square A square root, we will get sin A. Now what? Now just we can split and write it like this, 1 by sin A plus cos A by sin A. So 1 by sin A is cosec A. Plus cos A by sin A is cot A. So you can solve the root questions in this manner. Rationalize the denominator and it becomes very easy. Let's see the next question, number 33. So look at this question. It is similar to the previous question that we did. Here also in the root we will try to rationalize the denominator. So LHS we will write 1 minus sin A upon 1 plus sin A. Now here the denominator is 1 plus sin A, so we will multiply it with 1 minus sin A. And numerator also we will multiply 1 minus sin A. So what do we get? Look at the numerator, 1 minus sin A into 1 minus sin A. We can write 1 minus sin A the whole square upon. It is 1 plus sin A into 1 minus sin A. We can write 1 minus sin square A. Now 1 minus sin square A under root, so which equals to 1 minus sin A. And upon 1 minus sin square A you can write cos square A. So it will remain in root cos square A. So root 1 minus sin A whole square is 1 minus sin A, and this is root cos square A. Now root cos square A is cos A. So we will write 1 minus sin A by cos A. And now again we will split it and write 1 by cos A minus sin A by cos A. So 1 by cos A is sec A. We will write sec A minus sin A by cos A is tan A. And we are done. So exactly we did like how we did question number 32. We did this question and you can solve. So mostly all the root questions are of this type and you can easily solve by rationalizing the denominator, right? Let's see the next question, question number 34. So let's see question number 34. We have cot square A by cosec A plus 1 the whole square. Now here, since this is cot and here we have cosec A plus 1 the whole square, we will try to write this cot as in the terms of cosec. Like we know the identity 1 plus cot square A equals to cosec square A. So cot square A we can write cosec square A minus 1, and that's what we will do over here. So we will write cosec square A minus 1 upon cosec A plus 1 whole square. So we can write this as cosec A minus 1, the numerator, cosec A minus 1 into cosec A plus 1. So cosec A minus 1 into cosec A plus 1 upon cosec A plus 1 the whole square into cosec A plus 1 I will write. Now I can cancel cosec A plus 1 and cosec A plus 1. What I am left with is cosec A minus 1 upon cosec A plus 1. Now I have to get it in the terms of sine. So now I will write cosec in terms of sine. And first let me write this cosec A minus 1 upon cosec A plus 1. Now let us write this in the form of sine. So we will write, so it is 1 by sine A minus 1 like this, 1 by sine A minus 1 upon 1 by sine A plus 1. Now we will simplify the numerator and denominator. We will get 1 minus sine A by sine A divided by 1 plus sine A by sine A. 1 plus sine A by sine A. So if you simplify this, you will get 1 minus sine A by 1 plus sine A. We are done. Let's see the next question, question number 35. So, let's see this question number 35. How do we solve this? Simply we will write for tan sine by cos and let's try solving it. So, LHS, we will write cos A by 1 minus sine A by cos A. And this one will remain as it is. So, we will write sine square A by sine A minus cos A. Now what? Let's simplify the denominator. So cos A by cos A minus sin A by cos A. And this will remain again as it is. Sin square A by sin A minus cos A. Now what? Now let's simplify this. This will become cos square A by cos A minus sin A plus sin square A by sin A minus cos A. Now we will take LCM, but see here we have cos A minus sin A and here we have sin A minus cos A. So what is the rule that we have to remember? If we write this as minus, if we change this sign, this will become cos A minus sin A. So we will write cos square A by cos A minus sin A, and we write this minus, then this will be sin square A and the denominator will become cos A minus sin A. Now the denominator is same, so it becomes easy to solve. We can write cos square A minus sin square A upon cos A minus sin A. So cos square A minus sin square A upon cos A minus sin A. Now what? We can write the numerator as cos A minus sin A into cos A plus sin A. So let's write cos A minus sin A into cos A plus sin A upon cos A minus sin A. So we will cancel this and we are left with cos A plus sin A, which is the RHS. So see, very simple question this was. Simply by putting sin A by cos A for tan A and solving, we get the RHS, right? Let's see the next question, question number 36. So let's see question number 36, how to solve it. 1 minus tan theta by 1 plus cot theta, the whole square. Again, we will write tan theta sin by cos and cot cos by sin, and let's see if we are able to get it. So we will write 1 by sin theta by cos theta upon 1 by 1 minus cos theta by sin theta, the whole square. Next what? Let's simplify this. Cos theta minus sin theta by cos theta. Cos theta minus sin theta by cos theta, and upon sin theta minus cos theta by sin theta. Sin theta minus cos theta by sin theta. And this whole thing square is also there. Now what should we do? We should only simplify this. So let's write cos theta minus sin theta by cos theta. Cos theta minus sin theta by cos theta into sin theta by sin theta minus cos theta and the whole square. So now what? Now this is cos theta minus sin theta and this is sin theta minus cos theta. We cannot cancel. So what should we do? We will take minus common and we can write it like this, that cos theta minus sin theta by cos theta into sin theta upon, we took minus common, this becomes cos theta minus sin theta. Right? And now we can cancel cos theta minus sin theta. So what remains here is minus 1. So we can write, and we have whole square also. So we can write this as sin theta by cos theta and minus. So minus sin theta by cos theta the whole square, which is minus tan theta the whole square, which will give us tan square theta. And that's what we had to prove. So in such questions, like if you have to cancel, here we have cos theta minus sin theta, and here we have sin theta minus cos theta. So if you take minus common, it becomes cos theta minus sin theta. You can cancel, and here you have minus 1, and therefore it becomes sin theta by minus sin theta by cos theta, which is minus tan theta the whole square and tan square theta. You can solve this question like this, right? Let's solve the next question, question number 37. Let's look at question number 37. For tan, let's write sin by cos. So cos A plus 1 plus sin A plus sin A by cos A. And now let's take LCM. 1 plus sin A into cos A. And what we get over here, we get cos square A plus 1 plus sin A into sin A. Now what? Now let's simplify the numerator. So cos square A plus sin A plus sin square A upon, let's keep the denominator same, 1 plus sin A into cos A. Now what? Now cos square A plus sin square A, we can write 1. So this will become 1 plus sin A. So 1 plus sin A upon 1 plus sin A into cos A. So we can cancel 1 plus sin A and we get 1 by cos A, which is sec A. And that's the RHS. So very simple question. We just wrote tan and sin by cos. Keep solving and you get the RHS. Simply. Let's solve the next question, question number 38. Let's look at this question. Here also we will write this as sin by cos and cos by sin, and let's try to solve it. So we get sin theta plus cos theta into sin theta by cos theta plus cos theta by sin theta. Then let's take LCM and this will remain as it is. So sin theta plus cos theta into sin theta cos theta, and we get sin square theta plus cos square theta. So what we can write? We can write sin theta plus cos theta into 1 upon sin theta into cos theta. Now what? Now let's write this by, we can write it like this, sin theta by sin theta into cos theta, and plus cos theta upon sin theta into cos theta. So we get very easily, we can write 1 by cos theta, which is sec theta, plus 1 by sin theta, which is cosec theta. So we get sec theta plus cosec theta, and that is only the RHS. So here also very simply, just by writing sin by cos and cos by sin, we are able to do most of the questions, right? Now let's see the next question. So look at this question number 39. We have LHS is equal to that, and we have to prove it. Now the RHS looks complicated. So RHS also we have to solve. Let's solve the LHS first. So LHS 1 plus sin square A by cos square A plus 1 plus cos square A by sin square A. Now what? So cos square A plus sin square A, cos square A plus sin square A upon cos square A. And here sin square A plus cos square A, sin square A plus cos square A upon sin square A. And here we can write it as 1 by cos square A plus 1 by sin square A. Now let's solve the RHS and then again we'll come back to LHS if we have to solve it further. So RHS if we solve, what we can write? 1 by, let's take sin square A common. So we will get 1 minus sin square A. And 1 minus sin square A we can write cos square A. So we will write 1 by sin square A into cos square A. Now we can write 1 as sin square A plus cos square A. So we will write sin square A plus cos square A upon sin square A into cos square A. Now if we split it, so what we will get? We will get sin square A by sin square A into cos square A plus cos square A upon sin square A into cos square A. So this will cancel and this will cancel. So we are left with 1 by cos square A plus 1 by sin square A. 1 by cos square A plus 1 by sin square A. And this is the LHS that we had got. So we can prove it. So here what we did, we are only taking common from the RHS. We get 1 minus sin square A. We write that as cos square A, but then we are not able to solve it. So numerator we can write for 1, we can write sin square A plus cos square A. And just split it and you get 1 by cos square A plus 1 by sin square A. And this is how we can solve question number 39. Let's see the next question. Let's solve this question number 40. So let's write it LHS as root 1 by cos square A plus 1 by sin square A. And then we have cos square A into sin square A. And numerator we have sin square A plus cos square A. So this can be written as 1 numerator and denominator we have cos square A into sin square A. So we can write this as root 1 is 1 upon cos A into sin A. Right? 1 upon cos A into sin A. And now we can write 1 as sin square A plus cos square A. So sin square A plus cos square A. And what we get? Upon cos A into sin A. And now like we split, we can write sin square A by sin A into cos A plus cos square A by sin A into cos A. And see, we can cancel 1 sin A and 1 sin A, cos A and 1 cos A. So we are left with sin A by cos A. We can write that as tan A. And plus, we are left with 1 cos A upon sin A, which is cot A. And that's what we had to prove. And very simply, we can, by just writing sec as 1 by cos and cosec as 1 by sin, keep solving. And when here you get 1 by cos A into sin A, then in order to get tan and cot, we can write 1 as sin square A plus cos square A, solve and you get the RHS. So very simply, we are done with question number 40. Let's solve question number 41. Let's solve this question. And in the same manner, let's write tan as sin by cos, sin A by cos A plus cos A by sin A into 1 by sin A minus sin A into 1 by cos A minus cos A. Now, only simplifying, so cos A into sin A. So we get sin square A plus cos square A. And here 1 minus sin square A by sin A. And here 1 minus cos square A by cos A. Now what? Now sin square A plus cos square A we can write 1. So we will write 1 by cos A into sin A. And 1 minus sin square A we can write cos square A. So cos square A by sin A. And into 1 minus cos square A we can write sin square A. Sin square A by cos A. So see, cos A, we can cancel and cos square A. So 2 cos A from the denominator and cos square A in numerator we can cancel. And same thing, sin square A in the denominator and sin square A in the numerator. So we get as 1. And this was again a very simple question. Solve, put the values tan sin by cos, cot sin by cot as cos by sin. Solve and you get the answer, right? Let's see the last question, question number 42. Let's look at question number 42. 1 plus sin theta whole square. We will write in the form of a plus b the whole square. So a square plus b square plus 2ab plus here also a minus b the whole square. So a square plus b square and minus 2ab, which is minus 2 sin theta. And denominator will remain 2 cos square theta. Now here we can cancel sin minus 2 sin theta and plus 2 sin theta. And we get 1 plus 1, which is 2. So 2 plus 2 sin square theta, because sin square theta plus sin square theta, upon 2 cos square theta. Now let's take 2 common. So 2 into 1 plus sin square theta by 2 into cos square theta. Let's cancel. So we get 1 plus sin square theta by cos square theta, which can be written as 1 by cos square theta, 1 by cos square theta plus sin square theta by cos square theta. So which means sec square theta plus tan square theta. And with that, we have completed questions 31 to 42 and reached the end of our Trigonometric Identities series. Across these 4 parts, we have solved all 42 questions from the R.S. Aggarwal book that I followed. I hope these step-by-step solutions have helped you understand different approaches to proving trigonometric identities. If you found this series helpful, please like, share and subscribe to Learn Smart with Sweta. Thank you so much for watching and all the very best for your exams.